So tonight's homework has to do with graphing parabolas that are in vertex form. It's on page 15, the 1.2 exercises, and the problems are these, 3 through 12. I'm going to demo number 7, and you can actually use the same process for all of these problems. Let's get some graph paper up here. And number 7 is the function g of x equals -4 parentheses x minus 2 close parentheses squared plus 4. So there's my problem. I'm asked to use the vertex form, and the vertex form looks like this: y equals a parentheses x minus h squared plus k. That a tells you whether the parabola is opening up or opening down. If it's positive, it opens up. If it's down, it is negative. I always remember positive is happy, smiley face, negative, sad, frowny face. That sort of helps me remember which is which. It also tells me how much the parabola is opened. So this tells us whether it's opened a whole lot or just a little bit. The other two numbers that you have to pay attention to are whatever the h and whatever the k are. And the h and the k will give us our vertex. So the h actually gives us the x coordinate, and the k gives us the y coordinate. And when we plug this into our formula or into our graph work, we're going to remember to take the opposite value of x, or sorry, the opposite value of h. And the reason for that is that in the formula, we're subtracting h from x. So we'll see that here in a minute. So let's see, vertex. Oh yes, and the other part that we want to do is the axis of symmetry. So that's going to be a vertical line that goes through the middle of the parabola, and its formula is x equals some number. In this case, it'll be h. So axis of symmetry is going to be x equals whatever h is. And that's pretty much all that I need to actually graph this. So let's do the problem. So first step is probably to find a, find h, and find k, because those are all the things that I have to replace in my formula, not the x, the h, and the k. So let's see, a in my formula is this number outside the parentheses. So a is -4. And h, and the problem is this number right here. So I'm subtracting 2. Remember, I was going to write the opposite of whatever that was. So it'll be a +2. And then k is going to be whatever number I'm adding and subtracting. And in this case, it's a +4 plus 4. So there's h and k and a. This is my first step. Second step is going to be to write what the vertex is. So the vertex, and the vertex is always going to be whatever h is and whatever k is. So the vertex of my parabola is 2, 4. And I need to find my axis of symmetry. So that'll be x equals whatever h is, right? And h is 2, so my axis of symmetry is x equals 2. And now I'm going to put this piece of information and this piece of information on my graph. So let's zoom out here again. Make a set of axes. Here's my x, and really the function isn't y, it's g of x. I'm going to write g of x along my vertical axes. I'm going to graph my vertex 2, 4, over 2, up 1, 2, 3, 4. And I'll draw in my axis of symmetry, which is just a dotted line that goes right through the middle of the parabola. And I'm going to label that x equals 2. All right, so I've got my vertex, I've got my axis of symmetry. Now I need to find some more points. I'm going to notice a couple of things. And the first thing I'm going to notice is that A is negative. So that means that my parabola is going to be a frowny face one, right? Because A is a negative 4. So that means that all the points I'm going to find are going to be heading down in this direction. I don't know exactly where yet, but I know they're going to be going in the downward direction because A is negative 4. I'm going to figure out just where those points are by using my original formula. And the original equation in this problem was this guy right here. So I'm going to use the g of x equals negative 4 times x minus 2 squared plus 4. And I'm going to plug in some values that are on either side of my axis of symmetry. So I'm going to write down my equation here. Oops, let's get a different color. We'll use green. So g, I guess that's red. Let's try green. Come on, green. There we go, green. So g of x equals negative 4 times x minus 2 squared plus 4. And I'm going to take some values on either side here. So let's try what happens when x equals 1. So when x equals 1, what happens with g of x? Well, let's see. G of x equals negative 4 times 1 minus 2 squared plus 4. So I'm just really plugging it in right where x is. I'm plugging 1 in for x. What happens to g of x when x equals 1? Let's go ahead and do out this arithmetic. So 1 minus 2 is negative 1. Negative 1 squared is positive 1. 1 times negative 4 is negative 4. And negative 4 plus 4 is 0. So when x is negative 1, or when x is positive 1, excuse me, g of x is 0. And there's another point that I could plot on my graph. Oh, it's right where I made a point. So I'm going to plot that 1, 0, but I'm also going to plot it reflected on the other side of the axis of symmetry. So I've got 2 points here. One on the left and one reflected over onto the right. I actually end up with 2 points out of this whole deal. 1, 0, that's the one I got from plugging in. And 1, 2, 3, 0, I got by reflecting over. So this I got from substituting, plugging in. And this one I got from reflecting. Let's do that same process with one more point. So I went to a 1. What happens if I go to 0? So what if we go right here? Let's do that in a different color. If we go to 0, what happens when I plug in 0? So g of x equals, same equation here that I've been using all along, negative 4 times x minus 2 squared plus 4. And I want to know what happens when x equals 0. So I'm going to plug 0 into this. G of x equals negative 4 times 0 minus 2 squared plus 4. And I've got some arithmetic to do. 0 minus 2 is negative 2. Negative 2 squared is 4. Negative 4 times 4 is negative 16. And negative 16 plus 4 is going to be a negative 12. So I've got another point here I can graph. When x is 0, g of x is negative 12. Let's go ahead and graph that one. So 0 and then down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this I got from substituting, so plugging in, and now I'm going to get one by reflecting over that axis of symmetry. So I'm 2 away from the axis of symmetry on the left, which means I have to go 2 away from the axis of symmetry on the right, and I'm going to get another point. This is point number 5 for my parabola. So it's 1, 2, 3, 4, negative 12. Now let's go ahead and connect these. Zoom out again. And let's see, let's connect them in black. So, kind of a messy parabola I've got going here. But all the time I'm going to do exactly these same steps. So the very first step that I take is to find A, B, and C. That's the first thing that I'm doing. Second thing I'm doing is figuring out what the vertex are, H and K, and what the axis of symmetry is. Third thing I'm doing is figuring out some other points. So I picked something that was near the axis of symmetry. I picked 1 and I plugged it in. Got a value of 0, plotted 1, 0, and then I reflected that point over the axis of symmetry and repeated that process with a different value. Plugged in 0 this time and got negative 12, and then reflected that point over the axis of symmetry. So I'm going to do another one in the next video if you want to see another problem from homework. Make sure you're emailing or calling if you have any questions.